Hello, my name is Corey McCall, and in today's presentation we're going to discuss conducting a chi-square test of independence. First on the agenda, we're going to review what a chi-square test of independence is. Then we're going to move on to our first chi-square test. Next, we're going to look at our second chi-square test, then our third chi-square test. Then next, we're going to go over Cramer's V interpretations, discuss some takeaways, and then open the floor up to questions. So a chi-square test of independence. In order to review that, we have to consider that to discover whether portions in one variable differ from portions in a second variable's value, a chi-square test of independence must be conducted. So a chi-square test consists of determining if there is a relationship between two nominal variables. Its statistic is a distribution-free tool designed to analyze group differences when a dependent variable is measured at a nominal level. We use it when there are nominal values containing two or more possible values. The chi-square test is commonly followed up by a Cramer's V strength test as to determine how strong a data set was used in this chi-square test if a significant result has been obtained from that chi-square test. A Cramer's V test determines the strength of the data used in the chi-square test so as to be a credible analysis. In our first chi-square test of independence, we're going to discuss the number of cars versus the number of payment defaults. We're going to assume the alpha is going to be 0.05 using the tool of PSPP with a degree of difference of 9, number of cases is 150, and with a p-value of 0.375. So our null hypothesis states there is no relationship between the number of cars and the number of payment defaults. And then the alternative hypothesis states there is a relationship between the number of cars and the number of payment defaults. And as a result, the p-value is equal to 0.375. With 0.375, it's actually, the significance is higher than 0.05 of the alpha, meaning showing that there's no relationship that has emerged between the number of cars and the number of payment defaults. In our second chi-square test of independence, we're going to take a look at the level of comfort versus the number of payment defaults. Our null hypothesis states there is no relationship between the level of comfort and number of payment defaults. The alternative hypothesis states there is a relationship between the level of comfort and the number of payment defaults. The chi-square states that the value is 9.75, again with the cases being 150 cases and degree of difference is 9, that there's a p-value of 0.375. Again with the alpha constant being at 0.05, the p-value is higher than the alpha constant, meaning that there is no relationship between the level of comfort in the test and the number of payment defaults. No relationship exists. In our third chi-square test of independence, we're going to discuss the number of cars and level of comfort. Our null hypothesis states there is no relationship between the number of cars and level of comfort. The alternative hypothesis states that there is a relationship between the number of cars and level of comfort. As a result of the test, we have a chi-test of 450. Again, the number of cases is 150. 9 degrees of freedom. P-value is equal to 0.00, which is less than the alpha constant of 0.05. And if it's less than 0.05, then there's a significant there's a significant difference showing there is a relationship between the number of cars and level of comfort, and Kramer's V is equal to 1, which showing that is a perfectly symmetrical relationship. So if we look at the Kramer's V interpretations, we can look at there's no relationship at 0.00, but if you take it to 0.15, there's a very weak relationship, versus 1.0, which is a perfectly symmetrical relationship. Takeaways. A chi-square test is used to determine if there is a relationship between two nominal variables and if the first variable has relations to values in the second variable. If the result of the chi-square test has significance less than alpha, the null hypothesis will be rejected and Kramer's value will be used. Kramer's V can determine if there is a strong relationship interpretation as represented by numerical indicators of strength association. If Kramer's V is equal to 1, the data relationship represented in the chi-square test is symmetrical. We will now open the floor up to questions. If there are any questions, please contact me. Thank you.